Logic gate. It is a basic building block for constructing constructing any digital device. If you want to if you want to build any digital device, okay, any digital device like our mobile phones, okay, like our LED TV, each and everything, okay, these all things are what actually created by using logic gates. Okay, so any electronic device, the basic building block is what? Logic gates. The basic building block is what? Logic gates. Remember this point very well. So basic building block is what, sir? Logic gate. That is the basic building block. Okay, so whatever the device we have, in that device we have gates are used. Gates are used to construct that device. Okay, there are several kinds of gate. Okay, there are seven kinds of gate altogether. There are seven types of logic gates. Okay, what are those? Look at, the first one is what? And gate. Let me give you the numbering. The first one is what? And gate. This and gate is what? Represented by dot. Now number two is what? Or gate. This or gate is what? Denoted by plus. It is denoted by plus symbol. Or gate. Now the third one, not gate. Okay, not gate. This not gate is what? It is an inverter. Not gate or inverter. Okay, so it is denoted by what? Let's say if you have A, then it is denoted by A bar. Okay, it is denoted by A dash or A bar. A dash or A bar. Now fourth one is what? Fourth one is what? NAND gate. NAND gate. Okay, NAND gate. It is denoted by what? Of course, if you have what? Let's say A dot B, then it is what? A dot B whole bar. A dot B whole bar. If you want to write here also you can write A dot B. Here also you can write what? A plus B. Okay. So this is what? NAND gate we have. NAND gate. Now, what is the number fifth? NAND gate. NOR gate. NOR gate. NOR gate. Okay, what is the fifth one? NOT gate. Now you know what is NOR gate? Look, OR gate what we have? A plus B. A plus B, here what we have? This is the NOR gate. This is the NOR gate. Now, AND gate, OR gate, NOT gate, NAND gate, and what? NOR gate. Okay. Now what about six? Six is what? XOR gate. XOR. This is also known as exclusive OR. Exclusive OR gate. Exclusive OR gate. You know what is the symbol? The symbol is something like this. A, we have this circle. In this plus we have a circle. In this plus we have a circle. I will create that circle, don't worry. In this plus we have a circle. Now what is seventh? X NOR gate. Okay, X NOR gate. X NOR gate is what? Exclusive NOR. Exclusive NOR gate. Exclusive what? NOR gate. Okay, again A, of course we have A, and this plus is in circle. This plus is in circle, and then B, and it's bar. Okay, now here we have what? Circle. This one. And here also we have what? Circle. So this is the seven gate, okay, altogether, and we will learn these seven gates one by one. Okay, just you take this one first: AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate. Okay, fine. Now let's start with a very basic gate. What is that? Let's say the basic, very basic gate. That is what AND gate. Okay, AND gate. So what is the symbol of AND gate? A dot B. A dot B. This is the symbol of AND gate. Okay. So as I told you, gates are used for what? Gates are used for, of course, for constructing what? Constructing. Definitely, we have what? Constructing the digital devices. Now you know, now these gates can be take inputs. This gate can be take inputs. Okay, these gates can be take inputs. The inputs is totally the total number of inputs is totally depend upon the formula. One formula we have, I'm telling you the formula. But that formula, by using those formula, you can happily what you will know that how many inputs we have, the total number of possible combinations, the total number of possible combinations. Okay, this is what the formula, this is what the formula. Now listen. So let's say A dot B and get. So okay, please wait. So what is the definition of and get, so better to continue with me. So what is the definition? Let's change me the color. Better to continue with me. So the and gate can have two or more than two inputs, can have two or more than two inputs, two and more than what? Two inputs, and it will always produce, it will always produce single output. It will always produce what? A single output. Remember this point very well. Okay. It will always produce what? Single output. Inputs may be two, three, okay, two or more inputs are there. Okay, two or more input signals are there. But output is what? Always. The output is always what? The output is always single. We have what? Single output. Okay. Now, let's say the truth table. What is the truth table? And what is the circuit diagram? First, let me give you the circuit diagram. What is the circuit diagram? How we are creating the circuit for this AND gate. Okay, if I want to create the circuit, how we will create the circuit? Let's see. Listen very carefully. So how I am creating the circuit. So let me change the color. So here we have what? One input. This is the another input. Okay. This is what? This is the diagram of AND gate. Now A and B are two inputs. A and B are two inputs. A and B are two inputs, and F is, assume that F is the output. Okay, F is the output. A and B are two inputs. F is what? Output. Correct or not? Yes. Now, if I want to find out the truth table, look at. I want to find out the truth table. Listen this point very well. Now I want to find out the truth table. Find out the truth table. Okay. So now I want to find out the truth table. The total number of inputs, or the possible number of input, the possible number of inputs depend upon formula called 2 to the power n. Depend upon the formula 2 to the power n. 2 to the power n, where n is what? The number of inputs. Listen well, listen very carefully. Where n is what? The number of inputs. Where n equal to what? Number of inputs. Okay, n is equal to what? Number of inputs. So now let's say we have what? 2 to the power n. 2 to the power n. In our case, how many inputs we have, Aditi? Two inputs. Very nice. So two inputs means what? 2 to the power 2. N is what? The number of inputs 2 to the power 2. 2 to the power 2 means what? The possible number of inputs are what? 4. 4 is the possible number of inputs. Are you getting my point? Look at the possible number of inputs depend upon a formula called 2 to the power n. So we will what? We will have, if the inputs are 2, the possible number of combinations are what? The possible number of combinations are 4. Please take this. Then I will draw the truth table. Okay, fine. Now let's see what truth table we have. Now truth table. So total number of inputs is what? 4. Truth table. So we have two inputs A and B, and what is the output? We have F. Two inputs are what? 0 and 0. Look at the first 0 and 0. Okay, 0 and 0. Next what? Total possible number of inputs are 4 or not? Yes, 4. So 0 0. Next what? A value is 0, B value is 1. A value is 0, B value is what? 1. Okay. Now 0 0 0 1 1 0 1 0 and what? 1 1 1 1. Okay. Now, sir, what do you mean by F? F is equal to what? How would you evaluate? F is equal to what? F is what? A dot B. How to find out the output? A dot B. Okay, A dot B. Here what? F means what? A dot B. A dot B. Correct or not? Yes. Now look at A dot B means what? Look at Aditi. A dot B means what? You just multiply. Very simple, very simple it is. You just multiply. Okay. So 0 into 0, what you will get? 0. 0 into 1, what you will get? 0. 1 into 0, what you will get? 0. 1 into 1, what you will get? 1. Tell me, is it clear? Yeah. Now, if you observe carefully, the conclusion you can find out what? What is the conclusion you can find out, Aditi? Look at here we have what? 0 0 0. This one. So whenever any input is 0, whenever any input is 0, output is also what? 0. Output is also 0. If any input is 0, output is also 0. So what you can write? You can write, if any input is 0. 0 means what? Low. If any input is 0, low. If any input is 0, that means what? Low. If the inputs are 0, low, then output will also become output will also become low. If any input is 0, low, then output will also become what? Low. Okay, this is the truth table. Okay, now you can take this. This is what? AND gate. So it would be more better if you take this one. Yes, now you take it. 0, if you are taking any input is a 0, output is always 0 in AND gate. That you have to remember. What you have to remember? Only simple thing. If any of the input is 0, output will always 0. Okay, here I have written 1 now. That's you're asking, right? It would be 0. Yeah, it would be 0. It's quite simple. If any input is 0, output is 0. Okay, is it clear? Yeah, okay, like that. It's very simple. Finding the truth table is very simple. You just multiply 0 into 0, 0, 0 into 1, like that you have to multiply. It's very simple. Okay, now we are moving to our next gate. What is the next gate we have? OR gate. Okay, what is the next gate? OR gate. Now let's see. File, new, So OR gate, OR gate, OR gate. How we can represent A plus B, A plus B. This is how we can represent the OR gate. This is how we can represent the OR gate. Correct or not? Yes, A plus B. Okay, now, sir, the same thing here also, no need to write the definition again and again. It will also what? Accept what? Two or more than two inputs. Okay, same. As we have AND gate now, same we have what? OR gate as well. OR gate is also OR gate what? We can accept what? Two or more inputs. Okay, two or more inputs we can accept. Okay, same. What is OR gate? If you write what, if you want to write the definition, you can write OR gate means what? The OR gate has two or more inputs, two or more input signal, two or more input signal, but only one output signal, but only one output signal. Okay, two or more what? Input signal, but only one output signal. Okay, now look at what is the circuit diagram. The circuit diagram of OR gate is something like this one. Here we have what? A and B are two inputs, and F is the output. Okay, A and B are two inputs, F is a output. Correct or not? Now let's see. A, B, and what? F as a output. F here what will happen about F? F is what? A plus B. Okay, quite simple. 0, 0, 0, 1, 1, 0, 1, 1. Now you just add. Okay, you can easily add this one. Very simple. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1. 1 plus 1 is what? 2. 1 plus 1 is 2. But in binary, we don't have 2, Aditi. In binary, we have what? 1, 0 and 1. Binary is the combination of 0 and 1 only. 0 and 1 only. So 1 plus 1 is what? 1 only. 1 plus 1 is what? 1 only. So what you can calculate from here, what you can write from here, look at. If any of the input is 1, if any of the input is 1, if any of the input is high, output will also high. If any of the input If any of the input is high, high means what? 1. High, that is 1. If any of the input is high, 1, output will also high. Output will also high. High, that is 1. Okay, please take this. Now, what is not gate? Not gate. So, not gate is what? Inverter. Let's say if you have A, okay, and it is inverter. It can be written as this one also, or at the same time, what you can write? You can also write what? Like this one, A bar. You can also write like this one. Okay, this one, A bar. Here, little thicker. Yes, this one. Both are applicable. A dash and A bar. Both are applicable. Okay. You can write anyone. Both are applicable. Now, so it is just like one inverter. Okay. It is just like inverter. So gate is very simple. Gate is very simple. Okay. Gate is very simple. It's just like a what inverter. And if you want to write down the definition, you can write down the definition as well. Sir, an inverter not gate. Okay, an inverter not gate is a gate with only one input signal. With only one input signal. Here we have only one input signal, Aditi. With only one input signal and one output signal. One output signal. Full stop. It works as an inverter. Works as a inverter. Okay, inverter means what? Just opposite. Okay. So let's say you have an input. Let's assume you have an input. Okay, here you need a bubble like this way. Okay, and then straight. So let's say if you are giving the input as what A, so what you will get here? You will get A bar. That is the inverter. Okay, you will get what? A bar. That is the inverter. Now if you go to the truth table, we have what? A and A bar. So if A value is what? 0 and 1, then A bar will be what? Just opposite inverter. A value 0 will become 1 will become 0. That's all. Is it clear, Aditi? You got it? Yeah, yeah, yeah. Take this one. Okay, fine. Now after this, what we have? After this, we have next is what? Next is look at. Next is what? Nand gate. Nand gate is the inverter of AND gate. Nand gate is the inverter of AND gate. Nand gate. So here what we have A dot B. AND gate is what? A dot B. What is the AND gate? A dot B. Okay, A dot B. If you have one inverter here, if you have one inverter here, then it will become what? It will become NAND gate. Correct or not? Yes. If you have one inverter, it will become NAND gate. Now, what is the structure of NAND gate? Okay, no need to write down the definition. Same. What is the structure? Just like AND. Look at this is the structure of AND. Look at your first diagram. If you look at your first diagram, it is just like AND. Only what you need to give here, you need to give here one circle. This circle is telling that it is what? NAND. It is NAND. It is NAND. Okay. So let's say here A and B are two inputs. A and B are two inputs, and F is the output. F is the output. Correct or not? So what you can write in the place of F? Of course, you can write what? F is the output. So what you can write? You can write F is equal to A dot B. A dot B, the inverter of A dot B. Okay. Now if you go to the truth table, look at truth table very carefully. A, B, and what? F. So again, same. We have what? 0, 0, 0, 1, 1, 0, 1, 1. Now, if you go to the output, look at it is an inverter. It is an inverter. So what you will do? You will multiply 0 into 0. Look at first you will multiply 0 into 0, 0, and you will invert it. That means 1. Then again 0 into 1, 0, but you will invert 1. 1 into 0 is 0, but you will invert 1. 1 into 1 is what? 1, but you will invert, it will become 0. Okay. So again same here. Input is 0, input is low, output is high. Okay. If any of the input is low, output is high. If any of the input is low, low means what? 0. Output will be high. Output will be high. That means output will be 1. Okay. Take this one. Okay. Now we have what? NOR gate. The next is what? NOR gate. You are getting now, Aditi? No problem? Yeah, fine. Now next is what? NOR gate. What is NOR gate? NOR gate is the inverter of OR gate. Inverter of OR gate. So how we are writing OR gate? OR gate we are writing A plus B. A plus B. Now if you invert this, it will become NOR gate. It will become NOR gate. Simple. Yes, fine. So now how would you create the truth table? Definition is almost same. So how would you create the truth table? Look at NOR gate. First, one input, another input. This is what we have. This is what we have. OR gate. This is we have OR gate, and here if you put this bubble, then it becomes what? Look at here what we have A, here what we have B, and here we have what? F. Okay, simple. So what the expression you can write? You can write F is equal to A plus B. F is equal to A plus B whole bar. F is equal to A plus B whole bar. Now how do you write the expression? A, B, F. So again what? 0, 0, 0, 1, 1, 0, 1, 1. You remember in OR gate we are adding now. In OR gate we are adding. NOR means what? Inverter of OR. So 0 plus 0 is what? 0. 0 plus 0 is what? 0, but it is 1. Now 0 plus 1 is what? 1, but it is adding. 0 plus 0 is what? 0. So 1. 0 plus 1 is what? 1, but it will become what? 0. Okay, 1 plus 0 is what? 1, but it will become 0. 1 plus 1 is what? Again 1, it will become 0. So what you can write, look at what you can write. Any of the input is high. What you can write from here, any of the input is high. If any of the input is high, output will become low. Correct or not? Yes. So if any of the input is high, if any of the input is high, output will be low. Now, take this. Good. Now we have only two gates. What is the next one? Next one is exclusive or XOR. That is what exclusive or. Most of the times I have seen students are facing problem in this gate. Okay, so just look at very carefully. Exclusive gate, exclusive or is what? Very simple. Look at it will be just like OR gate. It will be just like OR gate only, OR gate. But if you put here as a curve, okay, if you put here as a curve, now this will become what? Exclusive or. Exclusive or XOR. A, B, and here what? F. How we can write the expression? F is equal to A XOR B. A XOR B. How would we write XOR? This plus will be something like this one. Okay, sir, expression. Can we write the expression? Yes. A, B, and what? F. 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, sir, here you need to remember only a single point. What single point? It's very simple. Same input, output will be 0. Same input, output will be 0. That much only you have to remember. Same input, output will be 0. Correct or not? Same input, output will be 0. So where we are getting same input, look, here we are getting same input, output is 0. Okay, just listen where we are getting the same input. Here we are getting the same input, output is 0. Here what? 1. Here also 1. Here also 0. Same input, output is 0. That much only you have to remember. Okay. In XOR gate, you have to remember same input, output will be 0. Please write down. Okay. Now, so the last gate, XNOR gate, exclusive NOR. XNOR, exclusive NOR. Exclusive NOR gate. Correct or not? Yes. Sir, how we will write this exclusive NOR? A plus B, and here this plus is what? This one like this one, and this one NOR. Okay. So what is the truth? How circuit diagram? How would be the circuit diagram? Okay. It is NOR. So we have a circle here. We have a bubble. Okay. This will become what? This is, look at, this is NOR gate. This is NOT gate. But if you just draw this one, this become exclusive or exclusive NOR. This will become exclusive NOR. Now, if you go to the truth table, A, B, F, 0, 0, 0, 1, 1, 0, and what? 1, 1. Okay, 1, 1. Now, sir, here you need to what? Same input, output is 1. Same input, output is 1. Okay, just you put same input, output is 1. Here what? 0, 0, 1. Same input, output is 1. Correct. So here we have two inputs A and B, and here what we have F as a output. What expression I can write? I can write f is equal to a plus b, like this one. And here we have what? Not. Yeah, Aditi, please write down. So this is your logic gate is completed. Now, on the basis of this logic gate, you can draw some what digital circuits. Then we have Boolean algebra, some topics of Boolean algebra. Okay, okay. So that's all for today, Aditi. We have completed the logic gate completely. Okay, and maybe next class we will see our advanced topic on Python, and then we will jump to list collection topic. Okay, you revision all these seven gates. Okay, that's all for today. Thank you. Good night.